Hello, everyone, and welcome to the 45th episode of TechLifeSkills with Tanmay. My name is Tanmay Bakshi, and before we begin today, I do want to start off by saying a huge thank you, first of all, to Yisa Akinbolaji, the founder of the Creative Foundation, and his amazing team, of course, for honoring me with the Life Mentor Award in Winnipeg. Now, recently, I actually got in the mail a magazine with me on the front cover, as well as a letter from the Prime Minister of Canada and also a letter from the Lieutenant Governor of Manitoba. And so it really is an honor. I'm very excited by this, and so thank you very much, Isa. Thank you to the whole team at the Creative Foundation for making this possible. I really do appreciate it. Now, getting back to today's show, if you've heard any of my talks before, you know that I absolutely love to highlight the parts of technology that I think not a lot of people talk about, right? The parts that aren't hyped as much. Even though I think while they aren't as glamorous, they can be just as interesting or even more important, actually, than the ones that do get all of that attention. And really, today, I think we're going to do something similar, right? We're going to talk about the side of artificial intelligence technology that maybe we don't think about all that often. Specifically, we're going to be talking about the deployment of AI technology and, of course, a lot more, but that is going to be one of the things we focus on today. Because you see, putting an AI model into production is actually a lot more than just building an AI model, right? So, for example, take a look at, say, Apple's Face ID, right? So on your iPhone, your iPad, you can do Face ID. If you take a look at that system, you start to realize that Apple couldn't just build a facial recognition neural net and just call it a day, right? They couldn't just download a data set and train a neural network. You have to answer a lot of different questions about the user experience, right? For example, how fast can Face ID actually unlock? What angles does it work from on the actual device? What if on an iPad your thumb is obscuring a sensor? How can you be notified of that? Can it be tricked by different pictures or videos or maybe even a face mask? How much battery life does it take? Is there bias? Does it work equally for people of all different backgrounds, right? So these are all questions that you need to consider when you're taking AI into the real world. And so in order to dive into these challenges and how developers can actually solve them using different tools and techniques, we're being joined by a very special guest. His name is Animesh Singh, STSM and Chief Architect for Data and AI open source platform at IBM. He is also the Linux Foundation's Trusted AI North America Chair. And so now, without any further ado, let's welcome Animesh to the show and let's hear more from his experiences. Hi Animesh, how are you? Welcome to the show.
Thanks a lot. Thanks for having me here, Tanmay, and great to hear your honor from the Canada government, as well as getting a letter from Prime Minister. How often someone gets a recognition like that? So
Thank you.
kudos to you, and keep on advancing the field of machine learning and AI, right? As you have been doing.
Thank you. Thank you.
That's amazing. Yeah,
I really
yeah.
appreciate it. Thank you very much. It really was an honor to be a part of that event and to get that award. And so, this is something I'm really passionate about doing. And as a matter of fact, speaking of passion, I also want to know what it is that you're passionate about doing. And so, before we begin, before we dive into this world of artificial intelligence, I would love to start off by hearing a little bit more about the work that you do, animation. Maybe we could tell everybody a little bit more about, who you are and how you got to doing this.
Sure. So yeah, I've been with IBM for more than a decade. A large part of my initial career in IBM has been around cloud, right? So I was right at the forefront of cloud when it was, very in early stages, infrastructure as a service, platform as a service. Now, I think after doing that for quite a number of years, right, that's when, machine learning and AI world started interesting me. And one of the things, right, which I noticed, and I think in general the industry was going through that change where there was a lot of rigor around science.
Mm-hmm.
There was a lot of innovation happening around machine learning and AI, right? And more enterprises and users were getting onboarded. But I think what was happening also was that because of this new wave where these models need to be productionized, right? You need to create them at a regular basis. You need to be able to monitor them, you know, at a basis where you're able to detect for things. which tell whether your model is performing according to the real world expectations or not. uh, all these things were becoming more and more critical,
Mm-hmm.
right? More and more machine learning models need to be deployed in production. So that was the period, like around 3 to 4 years ago, when a lot of us, right, in the industry in general, woke to this power, right? But then the rigor started, and that's where I think the thing which I got passionate about was how to bring the rigor of engineering into machine learning, right?
Mm-hmm.
I mean, definitely, as I mentioned, there was a lot of emphasis on science, and there was a lot of great work happening there. But I think the part which was essentially missing was the rigor of engineering,
Mm-hmm.
where essentially you can do these things on a continuous basis. Your models can be deployed in production, right? There is auditability, there is logging, there is trace, there are metrics in place to check for the right kind of things you want to check, right? And the other thing is the shift, I believe, from an application world, right? I mean, the application world typically, when you roll out an application and you're giving an input to it, uh, you're probably guaranteed, if you haven't changed anything in the application, 1 month later with the same input, you're going to get the same output.
Mm-hmm.
That's not so much the case in case of models, right? I mean, models, exact same model, same version, same input. A month later, it's giving you a different output, right? Because models are living entity, they are learning, right? So a lot of the things have to be rethought, reimagined in terms of what production means, right? How often do we do rollouts? How do we do rollouts? How do we monitor while we are doing these rollouts, right? And when do we need to go back and check back all the way from the data and start, for example, retraining it,
Mm-hmm.
again running hyperparameter optimization or validation, right? So this was a field, right, which was ripe open for a lot of the engineering practices to come in, a lot of automation to come in, and that's where I've been focused on.
It's amazing to hear. It's so interesting to me as someone who's worked a lot on just development, but also on artificial intelligence, machine learning, to hear the way that you put it, which is there's a lot of that science rigor, but there isn't as much engineering rigor put into, or used to be put into at least, and arguably still even today, with like AI and machine learning technology. And specifically the sort of analogy that I guess you could use is a lot of the time when we have new technology or new capabilities, right, we end up building the software infrastructure to be able to leverage those capabilities and actually deploy them, right? So maybe a good example would be with Apple Silicon, right? So for the past however many years, Apple's been putting silicon into their own phones and their own iPads and whatever. Resources like, for example, RAM are incredibly limited. And so, you have to invent new techniques of even doing things like memory management. Like, for example, you can do automatic reference counting instead of garbage collection, which happens to be more efficient. And of course, if you're building your own CPUs, you can also build in your own instructions to do the reference counting for you really fast, right? And so Apple said, you know what, let's build our own language, right, Objective-C, Swift, to leverage these custom techniques. So they deployed that infrastructure out so developers didn't need to think about using reference counting. It just happened automatically, right? So bringing over maybe a slightly separate analogy, but over to the world of AI, being able to have the software and the infrastructure to say, these are the AI models that we have. As you mentioned, how often do we need to be retraining? Are we fine-tuning these consistently on new data? How are we detecting different issues with the models themselves, which we will also get into in a bit, and how can we keep rolling this out to users? So getting that infrastructure in place is definitely a key component of the machine learning pipeline. But before we get into, I guess, that component in more detail, I do want to take a bit of a step back and take a look at sort of AI as a whole, I guess. And specifically something that I'm really interested in is if you were to take a look at a project where machine learning is at the core, right? And I know that this is a bit of a broad, I guess, term, right? Because machine learning technology is a tool in a tool belt, right? It's not like projects revolve around machine learning necessarily, but machine learning can be a sort of make or break situation for a lot of different projects. So what I'm wondering is, for a project powered by that kind of AI technology, could you tell me what in general you think the sort of stages of a successful project like that would be, what the different components to it are, and what the sort of unique challenges are for one of the key pieces that you're interested in, say, for example, deploying AI-based systems?
Yeah, no, sure. I think, I mean, obviously, a lot of the machine learning, right, starts with your data, right, and the ETL phase of your life cycle, where essentially you are, creating these data lakes, engineering these, data systems where you are getting data from different entities, creating metadata and lineage around it. And I think a field which has now become also more prominent, which is getting more and more inserted into the data phase of the life cycle, is around feature engineering, right? I think feature engineering as a discipline wasn't there before. It typically was, yes, you have the traditional data oriented in terms of, extract, transform, load, cleanse the data, create the features, but they were not consistent, right? So essentially, as you are moving these to the next phase where data scientist, for example, needs to come and run training, right? Typically you see data scientists creating their own features, and then finally when the model gets deployed in production, right, the production deployers in general, for a lot of the, for example, reinforcement learning kind of models, right, they're using their own features, right? So that whole discipline of being able to carry and create features, right, within engineering discipline, and being able to reuse consistently across different phases of the life cycle, that's something which is emerging, and it is important. And rightfully at this particular point in time, right, the more and more folks are actually putting that rigor in practice. So I think that's probably one thing which was missing on the data side. Now obviously, we all know, your model is as good as the data you feed it, right? So definitely there has been a lot of focus around data governance and auditability, right? I mean, at times it's a lot of what is happening is a lot of enterprises are definitely training their model on their own internal data sets, but what's also happening, in a lot of cases you tend to get data from outside, right? You purchase it from a vendor, etc., right? And if these people leave, there is not a strong lineage around that. What was the quality of data, how many rows, right, did we procure, what were the features, right, which were the right there, what was the quality skew of the data. A lot of that is now being put into practice, where having a strong metadata around your data and lineage, so that you can actually go back and look at the quality of the data, right? That's becoming very, very important. And I think we see a lot focus coming from a lot of enterprises, right? Because they have realized that the machine learning models are as good as the data which is coming, and for them to be having this sort of strong engineering rigor in place on that side is very, very important. Now then we move towards the assuming you have covered the data side of the house, right, with the right governance, lineage, metadata tracking, having good feature engineering practices in place. You move to the model side, right? I think for the most part, the field which we see has become pretty mature and is used widely is the build side, where with the rise of Jupyter notebooks, right, obviously there is RStudio and others, right, and the laptops becoming more and more powerful, right? We do see, like, a lot of practitioners having that ease of getting started in terms of getting started with their laptops, building models. So we have to give a large kudos to the community in terms of handling that part really well. No, but what is also happening, and a difference there is that typically when you're developing an application on your laptop, right, your resource requirements are not that big, right? And there is not a lot of component in an application build time process, right, which actually needs humongous amounts of data, right? Now, so these are the two unique things, right, even in the build side of the model, right, where you may not be just satisfied with your laptop or your computing machine, right? You have to leverage, even for example, so running certain Jupyter notebooks, for example, where it is using TensorFlow libraries, right, which needs to leverage GPU under the covers, right? How many machines do we, like, developer machines, right, do we get with GPUs these days, right? So you may have to, okay, choose and launch these build environments, right, where you are, creating your data science, but still, you have to go to the cloud, right? Just starting from that single phase, right? The second thing is, okay, where is my data, right? Okay, part of my data is now dispersed across the cloud. There is, the Amazon S3 based block storage, which has become very, very popular mechanism of putting the data, right? But the proliferation of data warehouses and data lakes, which are now being spread across the big cloud providers as well, right? So you need to be able to gather and fetch that data from these multiple providers, right? So I think the build side of the house is also realizing that there is only so far we can go while doing this on our own machines, right? We have to be able to have technologies which are very well integrated with the backend cloud providers, right, where I can leverage the scalability and the power of GPUs. And the humongous amounts of data which is available to run my distributed training. Now, uh, the distributed training part is another area, right, where you can there are so many things which can be done. I mean, depending on where your GPUs are spread on a single machine or they are spread across multiple machines, whether then you are using a substrate like Kubernetes under the covers, right, to work with those GPUs, and how do the NVIDIA GPU device drivers work and perform with Kubernetes under the covers, right? There is a total discipline there in terms of how efficient you can get with the algorithms you choose, whether you use TensorFlow's parameter server approach, or you used an MPI algorithm, which is more optimized for GPU to DPU communication across machines. So a lot is happening there, right? Definitely, and then what we call people who have traditionally missed this field for 2 3 years, they're entering late, and they're saying, hey, forget, we don't want to do all this. We don't want to set up huge data science teams, or these scientists to run distributed training. We will go to a cloud provider. We have a lot of finances. We have a lot of money. Give us auto AI, right? Give us auto AI. We will, use as much compute as possible, run, hyperparameter optimization, neural architecture search techniques, and produce like 50 60 models at a minimum, and then choose the best out of it, right? We don't want to go through that whole previous part of the life cycle rigor, right? So that's an area, right, which is hugely becoming very popular, very emerging, especially with users and customers who have deep pockets, right? They can throw a lot of money, a lot of compute power at this and get it done without building a lot of the discipline in the previous parts of the life cycle. Now, once you're done, you have that initial model, you have possibly trained it, right? There is this whole validation even before you deploy, right? And that's a field in itself, right? A lot of the validation needs to be happening around how can you detect if your model is not vulnerable to adversarial attacks, right? If there are adversarially generated inputs which are coming to your model, can your model be fooled very easily to give predictions? So that field vertically, again, is an area where a lot of focus is. And last leg of the process, right? And I wouldn't say the last leg, right? Because again, let's say deploying your models in production, right? So you deploy your models in production. Okay, how do you actually deploy in a way so that the crux of your model, which is, for example, the predictor component, it's essentially leveraging the GPU, right? But there are some non so hungry parts of your model, right? Pre-processing and post-processing, for example, things which you take your tensors, I mean, which take something like a text from a user or an image from a user, convert it to tensors, which model, they don't need to use GPUs, right? They can actually run on CPUs, right? So how do you actually architect this kind of design in production where only the predictor part of your model is which is GPU hungry, is consuming that? Then the process of, okay, you have deployed your model, and you're probably deploying 50 100,000 models. You're getting to that maturity stage, and you're realizing that 50% of your models are not getting any traffic, or they're not being used as heavily as you want, right? You're probably getting traffic once in 2 weeks, once in 3 weeks, right? But they are consuming your heavy GPUs, right? And you're paying for those heavy GPUs in spite of those models not getting any traffic, right? So how do you actually ensure that you can scale to zero based on the traffic patterns, so that the models only which are frequently needed, right, they are the ones serving traffic, but the ones which are not, right, they are automatically scaled back to zero. And if there is the request uptake which happens, then you can start doing auto scaling, right, based on request count, right? So that whole area there itself, definitely, how do you consume, like how can it support multiple protocols like HTTP, gRPC, etc., is a field. And what I call the last leg is, then okay, my model is deployed, and now I get into day two. Okay, a lot of people think model is deployed, hey, we are done, job is done, let's go home, and finally we have completed this huge life cycle. But for a lot of people, the real work starts there. Putting models in production and having the responsibility of your brand, the brand of your company, being determined by the predictions of the model, right? We probably have heard instances where a lot of the times the way models are giving predictions, whether wrong, biased, in certain cases, judgments which are not qualified, people getting sued, people losing their jobs, right? So that's the real world repercussions of a model deployed in production and carrying forward your brand. So how do you actually put a strong set of capabilities around it to be able to monitor in live what your model is doing, also being able to monitor historically what your model is doing, being able to generate metrics, and then based on those metrics, make decisions, right? What do you need to do with that model? Is there a chance now to go back, retrain? Should we, when we are rolling out new versions of the model, how do we actually, split traffic so that, I'm doing more canary-based rollouts and progressive rollouts while monitoring the metrics, right? So I think this when you look at this build, train, deploy, and manage part of the machine learning lifecycle, right, there is a lot which is happening, and there is a lot which needs to happen, and each of these fields is a vertical domain in itself, right? You can probably spend the next 4 years just hardening one part of that field to get to that level and rigor of engineering, right, where you're very, very confident, hey, this deployed model is carrying forward my brand, right, and it's carrying it forward in the right way.
There's so much to machine learning that I think a lot of people don't think about at first. I mean, as you mentioned, each one of those individual segments that you mentioned is something that you could spend practically a lifetime researching and developing and advancing further. And what's really interesting is they all work with each other, right? Everything affects everything else. It's not something that you can just look at in complete isolation either. And so actually there are a couple really interesting points that you mentioned. First one that I want to start off on is your point of feature engineering. I think feature engineering is something that, with the advent of deep learning, a lot of people almost just forgot. Not necessarily forgot, but we thought, why do we need to do feature engineering when we have deep neural networks that can take our raw data and start to process it for us? And one of the issues that I see with that is that fundamentally you are asking a machine learning model to now achieve a more complex task and try and infer the pre-processing that you may already know how to do, right? I feel like one of the good examples would be a little while ago, I was doing a talk at an event, The Human Code, and I was featuring one of these new projects that I was working on around the intersection of like computer science and art. And this project used neural networks to augment songwriters by giving them, automated inspiration. So allowing them to use a neural network to generate lots of, for example, lyrical units that they can then go ahead and use in their own music. And one of the key things that I had done beforehand, before I even trained this model, was pre-processed the data to make it easier for the network to understand. Specifically, if you look at lyrics, they're very intrinsically tied to music, right? So for example, if there's a gap in, for example, let's just say there's a sentence, if there's a gap in between the sentence, that would be separated by a new line. So you'd have the first line, the second line. But then you could also just have an entirely different sentence after the new line. So that new line character now has two meanings. Either it's a gap in the music for a single sentence, or it's actually two separate sentences being delimited by that new line. You don't know which is which. And if I'm just expecting a model to learn that automatically, that's a lot more that I've asked of that model. And it needs to start to infer that using nothing but the labels of the next word, which isn't something these models are particularly good at doing, right? And so the first thing you got to do is look at the features you're feeding into the model, engineer them to be particularly good for the model that you're feeding them into, to make it so that the model's work is easier, so it can actually find the set of weights that you want it to find. Right? So that's one thing that I think is really important that people don't really pay as much attention to as they should. But also, what I found really interesting was your mention of auto AI. So I do want to go on a bit of a tangent on auto AI really quickly. And there's always the question that I get whenever we talk about auto AI on TechLifeSkills of, is auto AI going to replace human data scientists? And the thing that I always sort of go back to is, let's say we look at GPT-3. There were two tweets that really stood out to me from experts in machine learning about GPT-3. One was from Andrej Karpathy. He said that by uploading data or generations from GPT-3, we are actually polluting the future data sets that we're going to use for GPT-3. And that makes a lot of sense, right? GPT-3 is just trained on random internet data, and by uploading data from GPT-3, we're polluting its future data sets. And one of the responses to that tweet was, well, if we're using GPT-3 to generate the internet is never going to evolve. It's going to be a lot more of the exact same thing it's always been. Because, well, it's a mathematical model, right? It is just a bunch of statistics on data that we've already generated. If we're using it to generate more stuff in the future, that's never going to change. There's a finite amount of things that that model can do within a sensical manner, right? And so that brings us to the world of auto AI. And like, if you take a look at what Google did with AutoML before the transformer architectures were, a big thing. They used their neural architecture search to find recurrent cells, which were really good, better than LSTMs. And they did very well with that. But something to think about is that auto AI isn't creative enough to then say, hey, why use a recurrent cell in the first place when we could be inventing the transformer architecture, right? That neural architecture search is given a very specific objective. And no matter how good that is, the human creativity of, oh, there's a completely different architecture altogether that can solve this problem in a better or a different way, that is sort of where the disconnect comes in, which in some cases can actually be really helpful. And so I just want to really quickly get your thoughts a little bit more, depending on how much experience you have with like the auto AI component. What are your thoughts? Where does that fit in? And do you see it replacing humans in the future or really working with human data scientists?
I think it's going to be the latter, right? I mean, so to your point, right, there are elements of human creativity which, right, auto AI cannot replace, as you mentioned, Tanmay, right? So going back, when you look at, a lot of the more linear regression kind of models, right, things which essentially, work more on linear data and other things, they are good candidates, right, to actually throw a lot of compute, right, run auto AI, neural architecture search, run hyperparameter, choose the best hyperparameters in an optimized fashion, and be able to produce a set of models, right, which can then, be able to predict in a manner which you want, right? But again, the thing which we do tend to miss with auto AI is, even if you're producing like 50 to 100 models, right, by running these neural architecture search at a scale, it's going to be as good as the data set you have provided it to it, right? So a lot of the human ingenuity in terms of being able to identify the right features, the right set of features, which need to be fed even before, the auto ML experiments or auto AI experiments begin with, that cannot be replaced, right? And I think that's what is happening is, where a lot of people are thinking. And more so, like the companies and the individuals who have missed that initial bus of AI and now coming into it that, hey, here is my data, throw auto AI to it, right? And use as much compute as possible, right, to get to the conclusion. What they're missing is even with that and those techniques in place, right, typically the restrictions are that, it will probably work best with more, uh, logistical regression and linear data, right? The other part is that, again, for example, if you talk about feature engineering, like, I mean, typically this is a practice, right, which became very prominent in the Silicon Valley companies like Uber and Lyft, right? Initially, if you see, they have now production level feature engineering stores running, and the sort of data they needed was more now, which was not coming from the raw data which they are streaming, right? So, for example, if a driver is making 500 trips a day, that's good, right? But what they actually needed to train on was, how much was the average commute time? How much was the average tip, right? How much was the idle lag time, right? Now, these are the features which are not available in raw data by default, right? So you still need to have that uh, rigor of a team in place, right? A team of data scientists who can actually understand, right, and create those features, create a production level feature engineering store, which can then be fed back to your models while you are training. And it's also not while you're training, right, when you're actually deploying your models in production, right, and they need to be able to predict what is the next step, or what is the next, how much amount of time will this driver take. A lot of that then depends on the live streaming data which is coming in and the live calculation of the features, right? So I think, in short, the point like which you make, which is truly stands remain true, right? I mean, your models are as good as the data which is coming in, and for auto AI and auto ML success to be really successful, the rigor of engineering doesn't go away from the data side, right? Obviously, they can replace a large part of the manual training part of the machine learning lifecycle, where you have data scientists sitting and running trainings regularly for larger batches of intervals, then looking at the hyperparameters, tweaking them, right, and then modifying and then rerunning, right. I do see that auto AI can really be useful in that particular domain, right, where essentially it can heavily leverage the underlying scale of the compute and speed up that part of the process without much manual intervention, right? But you got to be doing the things right before that. Ensuring that what you're feeding that to that model, right, and the right set of features, etc., right, they are being done with that same set of rigor, right? You can't escape that because hey, we have auto AI techniques available.
So data scientists still have that job security. They're not being replaced by the tools built by themselves just yet, are they? Right.
No,
Okay.
definitely. I think that's one side of the field which, I mean, as you know, Tanmay, right? I mean, data side of the field has been, there for now probably 2 decades, right?
Mm-hmm.
People have been, manipulating, wrangling, creating the right data, right? And I don't see that part, being obviously, there is a lot of automation happening, right? But there is a lot of human intervention still required there in terms of producing quality data. I think the part which can heavily be engineered, automated, is definitely the machine learning and AI part of the life cycle, because I think that is ripe for automating heavily out of it. Yeah.
Right, right. In the real world, that makes a lot of sense. And so it's interesting to now see where exactly neural architecture search and stuff can also be helping in science. Like we've seen, like for example, with Go and with chess, right? When we actually created computer systems to start playing these games better than humans, that
Mhm.
humans were then able to extract insight from the way that these computers played to then become better themselves as well. Start to understand new strategies that these computer programs were able to discover just by playing quite literally billions of games. And so, it'll be interesting to see where that also fits into the science end of things. But now, though, I do want to get to a couple of questions from the live stream chat and also some more developer focused things as well. Starting off with a question from Shiva, since this one's a bit shorter. Shiva's asking, what benefits do you see of integrating Jupyter Notebooks and Kubeflow for the enterprise environment? So, are these two tools that generally work together, or are they in the same sort of boat? Can you tell me more about that?
Hi, Shiva. Great question. I think so. In essence, right? I mean, Jupyter Hub is essentially, something which we started with in the Kubeflow community, right, at the very beginning, right? And as we were running and while we were trying to run at scale, again, I mean, you are looking at something like 2.5 years ago,
Mm-hmm.
right? So Jupyter Hub was evolving, right? And a lot of the capabilities on Jupyter Hub were servicing, being able to run on top of in a container environment, right? In a then a container management platform like Kubernetes, right? Left a lot to be desired, right? So how do you actually communicate with the underlying persistent volumes, right? How do you scale, these different networks? How do you actually use an object storage under the covers, right? And we saw at that particular point in time quite a lot number of issues, right, while using Jupyter Hub as by default by wrapping it inside a container and orchestrating it through Kubernetes management platform. So I think the decision which was taken was, leverage the Kubernetes custom resource architecture, right, which has become very popular in terms of the cloud native technologies being built on top of Kubernetes, right? So a lot of the industry is assuming, Kubernetes is the substrate, right? I mean, the uh, like as you have seen, like a lot of the software has been built traditionally, right? Thinking, Linux is the operating system, and taking a dependency. Now a lot of the cloud native software is now being built, assuming Kubernetes is the operating system, right? And for all the right reasons. I mean, we see all the major cloud providers, right, heavily standardizing on Kubernetes, right? A large scale web companies now, rebasing their uh, cloud native applications and deployments all on top of Kubernetes, right? So with that becoming a standard, the need was and the ask was that we re-architect and reimagine this in terms of how will it, if someone has to build Jupyter notebooks to be launched on Kubernetes, how will it look like, right? So that's why choosing the Kubernetes custom resource architecture so that it's able to leverage the same Kubernetes APIs, the same Kubernetes command line for you to be able to launch Jupyter notebooks. That was the context, and that was the reason we, instead of going with Jupyter Hub, we tried Jupyter Hub for a period of time, but then shifted to building our own Jupyter implementation in the Kubeflow community. And there is now the Kubeflow Notebooks project is very, very well integrated with the underlying Kubernetes ecosystem, right? So by the virtue of leveraging, the Kubernetes custom resource architecture, you get the same capabilities. You get a very straightforward namespace isolation. So there are multiple users going, they can all get their own segregated namespaces in which they can launch their Jupyter notebooks. right? It can then leverage all the underlying storage subsystems, which are then exposed by the Kubernetes layer very natively, right? So be it the persistent volume claims, be it the S3 backed storage, be it the block storage, because of the fact that now it's built on the Kubernetes core architecture, right, and it's leveraging Kubernetes integration under the covers. All that storage can be leveraged natively because typically, yes, when you are using Jupyter notebooks in the context of an environment where the underlying layer is Kubernetes, right, you want to be able to customize it and heavily use it because a lot of the storage calls you will be making, right, you are typically going through now Kubernetes standards like CSI and other things, right?
Mm-hmm.
So that all those decisions are played out, and a lot of people heavily like it. It has been much more stable than what we had with Jupyter Hub packaged inside a container, and yeah, if hopefully that answers your question, Shiva. If you have any follow-ups, please reach out to me.
For sure. Hopefully that does answer your question. Feel free to let us know in the live stream if you have any more follow-up questions. And what I think is so interesting about what you mentioned is, as developers, we've always had these tools in certain areas that are like standards and that are like open source, things that everybody's contributing to, everything that everybody is able to sort of, work towards improving. Things like, for example, the Linux kernel, as well as, the whole GNU suite of tools. You have the LLVM compiler and all the things built on top of it, things like Clang and Swift. And what is so good about these tools is that they've become industry standards, things that everybody just uses by default. In a lot of cases, becoming better than the proprietary compilers that they're meant to replace, or proprietary, really, whatever software they're meant to replace, right? My favorite example, honestly, really is LLVM, because if you think about it, to think that, well, Chris Latner really, but then from there, Apple was able to start this sort of, or really get this open source project running, and now all sorts of companies are working towards contributing and really using that as their default compiler for all sorts of different architectures. It is really fascinating, right? Like we see IBM switching the XL compiler to an LLVM backend, and so much more. Google using it for all their projects by default. I mean, hopefully we have a Go LLVM backend that's stable soon, but that's a different topic. But now what I think is nice is that it's about time we also have infrastructure services like Kubernetes sort of in a similar position where we have this tool that all sorts of companies, IBM, Google, Microsoft, Amazon, whatever, can all contribute to and work towards making better. So now it's great to hear we finally have these sorts of infrastructure services as an open source tool that everybody's working on and working towards standardizing as well. I'm sure that's really helpful for all sorts of developers. And so now, though, I do want to get into a question that I think this one's a bit of a longer topic, so I want to open up that door now. It's a question from Sudarshan Bharti. They're asking, what are the latest technologies that enhance the risks associated with ML model integrity, explainability, fairness, and agility? We have AWS Clarify, Fairness 360. What are the current latest research? So,
I
enhances the
think
risks.
that's essentially the last mile problem, right? So as I mentioned, like, hey, my model is deployed, let's go back to right scenario when people now have to come back. Okay, that's not the end of the journey. In some ways, for a lot of companies, that's the biggest part in the beginning of the journey, right, where my models are carrying my predictions forward, right? So I think the in general the field and the area, right, which is becoming very important is, and I think we will see a lot more focus this year, 2021, 2022, going forward, is the model observability and model metrics, right? Once the models are running live in production, what are the things they are supposed to do? What are they supposed to do, right? They obviously are supposed to, at this point, a lot of companies are mandating that, your models, while deployed in production, they should be able to explain their predictions, right? And not only explain it to the end, consumer who is impacted by it, right? Obviously, if a model is deciding whether I'm getting, admitted to a university or my loan is getting denied or not, I need an explanation, right? Why did you make that decision? But it's also, the auditors in general, right? So a lot of the enterprise companies and companies, right, are putting a human in the loop there, right? Auditors who are looking at the historical predictions of the models, the associated explanations, and they have to be explained that, hey, why is this model over the course of last, 100 applications, rejected these 80 applications, and accepted these 20 applications, right? What was the reasoning? What were the rationale? What were the features which were looked at, right? And they the auditors and the humans in the loop, they need to be explained, right? So that's a explanation at that level. And I think now there is also a lot of focus, right, going back and explaining your data sets, right? A lot of people are actually putting, again, this was a rigor which was not there in the original data science world, but now, it's coming to the point where, thou shall be able to explain data sets right from the outset, right? Like the quality of the data, the features used, right? Is there a correlation between a particular set of features? For example, if it is a female, why is the loan amount which is approved 1/20th of the male when all the other features remain the same, right? So explain the whole data set to me, and why the data set, is distributed the way it is, right? So if it is a criminal justice data set, right, for example, you will expect it to be biased towards a particular race because, hey, historically this has been the data, right? But people are not taking it on an assumption level. There has to be a rigor of engineering. There has to be an explanation. So explainability is one key characteristic which is being demanded by a lot of enterprises who are now deploying models in production. And obviously, the you mentioned, SageMaker Clarify, right, for Amazon. IBM has OpenScale. What's an OpenScale, right, which strongly plays into that space. We also have a project called AI Explainability 360, which is part of Linux Foundation AI, and it's growing there. Now, there are a lot of other projects in open source, right, which are handling this really well. There is Lime, there is SHAP, all these projects, right, which are extremely popular. So as part of AI Explainability 360, for example, right, we give an interface so that you can actually leverage Lime and SHAP algorithms also through AI Explainability 360, right, instead of using native algorithms like contrastive explanations if you want. So that's a field, right, which is growing. A lot of algorithms are coming now. A lot of algorithms are also being developed in terms of being able to uh, generate explanations for black box models, right? So typically it's easier if you can look at the models, right, and you can generate explanations. But a lot of times what is happening, because the field of transfer learning is evolving so much, a lot of the times, when the handoff is happening, you are being given a model and you're saying deployed in production, right? And that model might have been developed probably, by teams outside your organization, and you're supposed to then, run transfer learning on top of it, customize it heavily for your needs, then deploy it. Given that it's a, black box model, let's say, very complex deep learning model, in that case, how do you generate explanations when you don't have, the actual insights, right? So the whole field of being able to train surrogate models, which are then being able to learn over the explanations generated by these black box models. And then, there are now these surrogate models are being trained over the explanations itself, right? And then generating more and more uh, comprehensive and more meaningful explanations as this goes along, right? So that's a field which remains very active in research, right? But obviously, all the different cloud providers, right, have launched these offerings, right, which are heavily focused on that side. The other thing which is happening, right, just in that, you mentioned, I believe, bias detection and mitigation, right? So hugely important thing, I would say, right? So uh, like, for a lot of reasons, I mean, IBM has always been at the forefront of this particular research, right? If you've seen, like, we launched AI Fairness 360, which is a toolkit for bias detection and mitigation, probably 2.5 years ago, when there was a lot of talk in the industry that, hey, this is the right thing to do, this is the ethical thing to do, but there was a lot of talk. There was not actual code base and technology. So IBM was at the forefront of being able to, take that toolkit and open source, launch it, and then leverage it heavily also in our production Watson OpenScale, right, which is essentially the product, right, which is now being deployed in a lot of enterprises. In fact, it has been deployed um, in financial industry customers. It has been deployed in customers in the retail industry, and it's helping in so many ways in terms of being able to detect bias in different use cases. Um, so that's something which we still continue to be focused on heavily in terms of being able to detect. Now, if you see, the traditionally the way to do bias detection and mitigation has been more about payload logs, right? So we collect. Oh, there's a lot of sun coming here. So there is a essentially, what you do to detect bias, you need payload logs in a sense that, as your models are deployed in production and giving live responses and getting live requests, you need to be able to collect historically a certain amount of data before you can run and these analysis algorithms, right, which can detect, okay, over a period of last, 1,000 predictions or 10,000 predictions, a million predictions, right, your model has been found to be biased towards a particular gender, race, or color. But in a lot of cases, you don't have that luxury. You can't wait for 1,000 predictions to be collected, and while those 1,000 predictions are being collected, your model is giving wrong results and biased results, so to say, right? When you're deploying your models in production, right? So I think there is a lot of focus now. How can we make this more robust while being able to act on live predictions, right? So if I only have that one individual request which has come in, that one individual response I'm giving in, can I still classify that your response is biased, right? Without having any access to historical data. So that's right, an area which is undergoing quite a bit of research in terms of being able to figure out how do we actually enable that. Now, one of the techniques, right, for example, Watson OpenScale is using is, right, for example, if you get a request and one of the features is mail, right, and your loan approval request is approved, you can behind the scenes just send a pseudo request, right, which just flips that feature from male to female and see if the response is different, right? So now that's one way, by just choosing your protected attributes, like your race. You can flip the race in real time. You can flip the sex in real time, right? All these protected attributes, and then you see the response back and see, hey, was the result any different because of that, right? So that's one way to just raise a red flag that every other feature remaining consistent just because I switched the gender, why is the model giving a different response? Now, in a lot of cases, you'll say that yes, it's genuine, or less. I would probably genuine is not the right word. In a lot of cases, it is because hey, the historical data set has been like this, right? For example, again, if I choose the criminal history data set, right, I will probably find it to be more biased against non-Caucasians, right? And because the historical data set is like that, okay, then what kind of techniques you can use to if your historical data set is itself biased, what sort of algorithms and techniques we can use to actually remove bias right at that outset, right? So I think that's an area, again, a lot of focus and a lot of research is happening on that, right? So all in all, right, very, very exciting field. Now the third thing which is happening in the same last mile problem is adversarially generated inputs, right? So on one hand, right, the field of GANs is important because it's giving you a lot of synthetic data. Instead of being able to use real data, you can generate, using these generate GANs, you can, create a lot of synthetic data on which you train your models, etc., right? And doing more with less data is becoming the theme for a lot of companies, right? But on the other hand, it's also creating this problem of fooling your models with adversarially generated inputs, right? So let's say, you're a bank and somebody, you give a check of $171 to someone, right? Hey, this is the check I'm giving to you. It's very, very easy to actually, generate an adversarial image of that check where the one can be a seven, and that adversarially generated output is indetectable to human eye, but it's very easy to fool a model to think of that one as a seven. So instead of 171, what gets debited from your account is $777 because both these ones were made, and the model was really fooled, right? So that's also happening because there is so much advance and um, research which has gone into in terms of creating synthetic data. Now that same synthetic data is being used to fool models deployed in production, right? So that's again an area of huge research. So hopefully, that answers your question, right? Where the latest research is happening, what are the latest tools and technologies, right, which are coming in that space. But obviously, we at IBM are very, very passionate about it, and that's one of the reasons, right? We are participating in the Linux Foundation AI. We have donated these projects around AI fairness, around AI explainability, and then adversarial robustness to Linux Foundation AI. The adversarial robustness team is also working with DARPA, right, the defense arm of United States, in terms of making that toolkit more robust to actually find and defend, the models which are being used in the defense side of the house, right? So a lot of work going on in that area. And I think one thing which is also happening is we are expecting a lot of regulations to come probably this year and next year, right? Starting from European Union, where what you can do with your deployed models and what sort of checks they need to pass is going to be mandated. So far, I think it was the right thing to do. It was the ethically important thing to do. But now, it will become something which is a law. So thou shall be able to, if your model is deployed in production, these are the requirements that thou shall explain, thou shall give me bias characteristics, thou shall be able to produce whether your model is vulnerable to adversarial attacks. I strongly believe these regulations are just going to knock at our door starting very heavily this year and next year.
Mm-hmm. I mean, I gotta say, there's such sort of complexity to these issues because they tie not only into the science of machine learning and the way that they're deployed, but also into the way that we operate as humans and as a society, right? Like, for example, with the bias thing that we've been talking about for a long time, from a if you sort of look at it from a detached from technology perspective, you see the sort of way that we societally represent bias, which is, for example, in the loan application, what if we switch the gender, right? For example, male to female. Well, what happens then, right? Does the model give you a different prediction? If so, why, right? And so these are things, and of course, I mean, it would be based off of the correlations in the data that the model was trained on. But then it also comes back to the question of, fundamentally within AI models, bias isn't just about what we code in or what we really think of bias as humans, right? If you think about machine learning models, they are fundamentally lazy. I think even humans are fundamentally lazy, right? Like, for example, we had, or I read this great blog post by my friend Timothy Duncan, and he was talking about how, what's led to the terrible policing situation in the United States is the fact that police departments were offered this incentive to just essentially arrest as many people as possible through the grant department, right? And so that led to the whole sort of the chain of events that happened that led to the state that we see today. And you see, the issue with this is that when we train machine learning models on this data that we've collected that is already fundamentally biased, because of the data that we're feeding in, and because of the fact that these models are, again, fundamentally lazy and are going to find the simplest possible solution to whatever problem we give them, what happens is they're able to figure out correlations, but they're unable to extrapolate necessarily the right causal links, right? So for example, even if we could determine that, hey, with the exact same set of characteristics, the male versus female switch, that's for some reason telling the model, hey, don't accept this loan application. Even if we're able to understand, yeah, it's because of this correlation in the data set, the model itself won't be able to explain the causality of that as to why exactly it wouldn't approve it for a female individual versus a male individual because of the fact that that data was never fed into the model. It does not have any kind of information to work off of, any sort of worldview to say, hey, this was my chain of reasoning to come to this conclusion. That's the issue. The data we're feeding in, we expect models to do that extrapolation for us. Now, if there's certain data points that we don't want them to be biased on at all, we don't feed them in, right? Like, for example, if we think, for example, gender is something that shouldn't even be considered when you're taking a look at a loan application from a mathematical perspective, that's something that in the feature engineering stage you would throw out altogether, right? And so that also ties into the fact that, as you mentioned, while this is its own vertical and could be researched and studied for quite literally a lifetime, it also ties right back into every other stage of the pipeline. So it's a complex balance of so many different factors that sort of come into this, and I also feel like the explainability portion, I think at a fundamental level, is also tied into that bias portion at the same time. So there's a lot of interesting work that you're doing. It's great to hear that IBM's donated the Fairness 360 toolkit to the Linux Foundation. I feel like that's really important to make it so developers can actually start to use this technology and start to normalize using these toolkits whenever you develop a machine learning powered app. especially one that makes important decisions for people's lives. So that's definitely great to hear. As a matter of fact, we actually have a follow-up question from Sudarshana. This one's about a slightly different topic, but Sudarshana is asking, how do we deal with anomaly detection during a production run? What are the techniques to determine whether a data point is an outlier or a new variable that needs to be considered in feature engineering?
So I think this is again one of those areas, right, which goes to the last mile problem, right? Anomaly detection, drift detection. So typically, uh, I think what is being required from a lot of the production model deployment systems is having a robust capability. First of all, to do a lot of this analysis, you will need historical data, right? So data which you are collecting, you cannot do, for example, something like outliers, you cannot detect unless and until you have a view of your model and having a set of requests and responses which you have collected over a period of time, whether it's over a particular number of predictions or for a period of a month, right? But you need to have a data set when your models are running live in production, right? So and that's a field, right, where, for example, if you look at more machine learning deployment systems, right, they're more focused on, okay, deploy the model in production more often than not. Applications itself, right, you deploy the application, right, but once it is getting a request, giving a response back, that's not something, right, which the production deployers have been focused on too much, right? But that shifts a lot on the machine learning side, right? You need to have a rigorous infrastructure in place so that you can collect all these requests and responses before you are able to do more advanced techniques around drift detection, outlier detection, etc., right? So for example, if you look at Watson OpenScale, right, I mean, typically under the covers, that's a product, right, which is focused on being able to collect payload logs, right? So if you've deployed your models on Amazon SageMaker or on Watson machine learning or on Azure ML, right, the engineering which Watson OpenScale is focused on, okay, if your models are being deployed on these cloud providers, right, and I'm collecting and they are giving requests and responses, how can I bring Watson's OpenScale to be able to run in conjunction so that it's able to capture all those requests and responses? And once it has captured in the right way, then I'm able to run these advanced algorithms, right? Or whether it's for bias detection, drift, or anomaly detection. So they use, for example, a REST API under the covers, right? So as requests and responses are coming in, right? So if you can forward it to that REST API, then it essentially takes it, stores it in a traditional database after post-processing it and making it ready for analysis. And then they use a lot of the algorithms which are developed inside IBM, right? IBM research algorithms to run more advanced analysis around that. In the open source, for example, in the Kubeflow project, the way we are doing it is essentially, we use uh, gateway, right? So CNCF, which is the Cloud Native Computing Foundation, has a project called Cloud Events, right, which is standardizing how the cloud events can be captured and processed. So it gives a lot of wrappers and protocols around it. So what we have enabled in Kubeflow serving is, for example, any request and response which is coming to a model which is deployed live in production, right? We create a cloud event compliant protocol out of it and a message out of it, and then we send it to what we call our payload logging system, right? Which in our case, the default implementation is using Knative eventing broker. It captures that request and response, and then it sends it, for quite a few folks, the way they are doing the deployment, that request and response is then just sent to a Kafka queue or a Kafka topic. And from there onwards, right, you can have, another post-processing container, which is then reading from the Kafka, either doing analysis on the fly and storing it in a DB, or a lot of people choose to take those requests and responses from Kafka, get it in the relational database according to the right schema, and then bring in more metrics algorithms on top of it, right? So then, those metrics algorithms go in the field of, right, which you're talking about, anomaly detection, drift detection, right? So there is a lot of open source projects. If you go to, Linux Foundation AI landscape, landscape.lfai, I can, send the URL after this, right? It lists a lot of these open source projects which can then be used to do more advanced analysis. Obviously, we talked about bias detection and mitigation, but projects which can do drift detection, which can do anomaly detection. And for example, Selden is a company, right, which operates in the model deployment landscape, right? And they have donated quite a bit of their algorithms in what is called alibi detect, right? Which is essentially focused around that area of being able to do drift detection and anomaly detection, outlier detection. So different algorithms which you can then use from there once you have the right set of data set, right, which we talked about, to actually classify that. Obviously, if you're getting products like what's on open scale, you get those things out of the box, right? And now once you have found these, for example, outliers and others, right? How can you make them more useful? So definitely, the work even doesn't stop there, right? Okay, I found bias, I found there are outliers, right? What do I do beyond that, beyond having a human take a look at it and say that something is wrong? So then being able to generate these metrics and send it into a system, right? So there is another project which we have called IBM Research originated it. It's called Iterate, right? And the job of Iterate is essentially, to look at some of these metrics, the production machine learning deployment metrics, and then, progressively roll out your new deployments of the model, right? So one thing is, okay, based on these metrics, do I need to retrain, right? The data set? Do I need to, run my hyperparameter optimization again? Right. So then, there are machine learning pipelines like Kubeflow pipelines, right, which play in that space. But then there is, okay, I have retrained, I have created a new model because, these metrics were not satisfactory. And now I want to roll out. So what Iterate provides you is essentially a progressive rollout where it's then, in real time, launching your new version of the model and slowly ramping up the traffic and from 1% to 2%. Then, collecting these metrics in real time, right? Drift, outliers. Okay, check, they're going good. Then increasing the traffic. At some point, if it sees that, yes, they are not being satisfied, there are still, more outliers coming. For example, in that case, okay, I will not, make this canary the default. Let me roll back the, deployment of this new canary version, right? So a lot of tips and techniques which can be used, along those lines. If you're interested, list of these open source projects which are specifically focused in those arenas, right? As I mentioned, drift detection, outlier detection, anomaly detection. I mean, just reach out to me, right, and I can forward you. There are many open source projects which are playing in that space.
Yeah, for sure. Open source technology really is a blessing for developers. And thank you for sharing. I will be putting Animesh's contact in the description, everybody, so you can reach out to him, LinkedIn, and however else Animesh would like, so that you can ask questions and find out more about this world if you have any more thoughts. All right, now a little bit more of a light question from Shiva before we get back into technology for a little bit. Shiva's asking a little bit far from the topic, but I want to ask, what do you love most about your role, so being a chief architect?
That's interesting. I think, you know, so I've always enjoyed in my career being closer to customers, right? And that's the part, right, which I definitely love the most, where, it's when the rubber meets the road, right? I mean, a lot of definitely, we need to have exciting ideas and a lot of ideas need to come, but it's essentially when the last mile happens, when the rubber is meeting the road and you have that sweat on the teams, right? The MLOps teams, DevOps teams, whatever you call it, right? Which are rolling out these things in production. You have sweat. You see customers nervous. I'm rolling out this model, right? And in a way, my brand is tied to it. And hey guys, is this going to be good, right? So being able to at that particular point in time be able to help out when technologies are being rolled out in production and being able to work in that particular vertical work stream, is probably what I enjoy the most, like hearing from my customers day in and day out, the challenges they are facing, and then being able to bring that back, right? So the promise of AI becomes a reality rather than just remaining a promise, because uh, like as one of our IBM VPs, Dinesh Nirmal, gave a quote, like it took me 2 months to develop my model, and it has been more than 11 months still not deployed in production, and that's a customer telling him that, right? And so the model was ready in two weeks, and then more than 11 months still not deployed in production, right? So that's the part, like, I really love, and definitely I'm passionate about the ethical implications of AI, right? This is something, right, which I have ingrained that, given that most of our life-changing decisions are now going to be based by models, I think at personally, at some level, we are all getting impacted even without us knowing, right? A lot of times when you are, applying for a loan, you're applying for your kids to be admitted in a certain school, certain university, certain college. You're applying for a job. Inadvertently, in a lot of cases, AI models are now making decisions to reject and apply, because just the sheer volume. If a university is getting 30,000 applications, it's not humanly possible to have a human in the loop for every decision, right? Now that poses a strong challenge, right? That we are not being discriminated against, we are not being biased against, and the things are being done in the right ethical manner if we are giving so much power to this one entity to make decisions for our life, right? So that's one thing, right, which keeps me passionate, that how can we advance that side of the field more and more and more, so that our trust in those predictions, and we can increase manifold, and we can essentially, if it's not the fact that I'm denied admission somewhere. It's more the fact that, hey, I was denied on wrong grounds, right, which rattles an individual more. And the point here is to make sure, even if the decision goes against you, you are explained enough so that you know that it was done in the right way, and you're not taken advantage of sort of by the system, or the system is disadvantaging you in some way, right? So I think that's yeah, these are the two things I would say, right? Uh, Passionate about the ethical implications, and ensuring that as more and more power we are giving to AI, we are putting more checks, and humans are obviously can over a period of time increase their trust in these systems. The second is, yes, just how does the rubber meet the road? When the rubber meets the road, how do we make sure that process is getting more and more and more hardened, productionized, auditable, and we are able to create right sort of lineage capabilities around it. Yeah.
Right. I love that answer because when Shiva asks what do you love most about your role, the sort of technical answer that you gave, I absolutely love it because it's the same thing with me. When people ask what do you enjoy doing most, and I go on like this technical rant of like different things that I love doing, and in code it's finally great to hear that from you as well. But now though, I do also want to ask another question from Nershad, and also really quickly, sort of going back to your point about being able to properly explain. I think that is a very key component, and even specifically actually with, again, sort of going back to what I mentioned before about the causality of things, not just the correlation. Hey, I was denied alone. Maybe the attention mechanism in this neural network could tell us, or maybe like a gradient based activation map could tell me that, hey, it was because of the fact that I was female that it denied. But then the model can't actually go ahead and explain why exactly that correlation exists in the data set. That, I think, is still a missing link. Being able to understand not just the correlation, but the causation of things is something that requires that sort of larger worldview and access to more data than just what's being fed into a lot of these models. So that's definitely something to be interested to look into in the future. We do have another question from Nershad Adulji asking, what are some open source tools to create data sets?
To create data sets, would you like to explain a bit more? Is he thinking more? I mean, like typically you start with a base data set, right? And then obviously there are a lot of toolkits, right, which are now available in open source to then create more synthetic data out of it, right? So I mentioned, for example, if you look at adversarial robustness toolbox, right, which we have donated to Linux Foundation AI, right, it allows you to create a lot of generates a lot of these adversarial inputs, what we call adversarial inputs, because that's what is feeding in our use case. But you can typically use that toolkit. I've seen quite a bit of end users and consumers using it to generate a lot of synthetic data, right, which they want to use for training, right? If that's what you are expecting from this question, right? I mean, typically you fetch your data set and then you clean it and you modify it, right, and you create features around it, right? But then these tools which are GAN based networks which are generating synthetic data out of it. Yeah.
Absolutely. I think the question is a bit more open-ended, so Nashad, if you have any sort of follow-ups or more details, feel free to let us know in the live stream chat. We will get back to you. But really quickly, there is another question, I guess, which is not related to this episode, so I will redirect you to another one that we held a little while ago. It's from Edu Ventures, asking, what are your thoughts on 5G and whether it harms birds or human mental ability? It doesn't, for sure. That's something that you can hear more about in the episode we did with Peter Linder, who is an executive at Ericsson working on 5G technology and marketing. So I will put a link to that in the description. Feel free to watch that episode and learn more about why 5G isn't harmful and why it is incredibly helpful to a lot of different technologies. So feel free to take a look at that. Also, another question here from Vabhov on the live stream chat, asking what will be the future of AI technology in the upcoming years in India specifically. The reason he's asking that, a little bit of backstory, he's a student learning AI and machine learning, and his parents are asking him what the future of AI is going to be in the upcoming years in India.
Very interesting. I haven't thought of it in that context, like specifically when you look at a country like India, right? What are the useful applications of AI there can be, right? Obviously we are all at this point, globally connected, right? So the globally connected themes will definitely continue to be playing. So as I mentioned, at least for this year and next year, and probably the year after that, the three things which at least I see, right, which are going to become more and more heavily focused. We talked about the ethical AI and the regulations and the rules coming out around it, and I think definitely India will play a huge role in it, right? We also already are seeing some implications of it, where at times the government is intervening and asking, right, in terms of these AI technologies being more regulated, being able to more explain their data predictions, right? So we do see there is quite a bit of evidence of the government taking a proactive approach in scenarios where ethical and regulated AI needs to come, right? So I think that is a field which will become pretty important. The second thing is, I think in general, the huge amount of farming base in India. Um, there is a company which we work with called Yara. It's a Norway fertilizer company, right? Which essentially has been using AI to create a digital farm replica of all their physical fields, so that they are able to predict much more ahead in time, right? The change in the seasons and when they should put more water or not, when they should be planting the seeds, what's the right time, right? Getting to that precise level. So I do see a lot of revolution happening in the farming side in India, where AI applications will be leveraged heavily to actually create these more and more digital farms, so to say, given that there is a strong precedence of that in India, and being able to then become more precise, more accurate in terms of when is the right time to crop the plants, when is the right time to actually take the harvest, which other years you should be shifting your cropping strategy. I think that's a field which will explode in terms of just the huge industry that is in India. The third thing, I think it's just the number of consumers, like the number of users in India. What will happen is, given we probably already see, right, between China and India, right, like more than 2/3 of the world edge devices are going to be there, mobile devices, edge devices, right? And the whole field of privacy preserving federated learning, where we are able to run AI models to on your edge device, whether it's your mobile phone, or you have a Google Home or an Alexa, or some Indian made voice activated device, right? But given just the huge humongous amount of it and the amount of data these two countries will generate, that will be huge. And being able to do that in a way where I'm not able to take the conversations you are having on your phone or the conversations you are having with your TV, but I'm still able to train the models locally there. But not only train, right? What I'm trying to do is I'm doing here federated learning, where yes, you are generating a piece of data, your neighbor is generating a piece of data, their neighbors and neighbors, right? I want to be able to take all that, training which has been done locally, combine them to produce these Uber models, right, which has that input, right? But I want to be able to do it in a privacy preserving manner. So I think that field of federated learning, given the huge consumer base in India, given the number of edge devices which are there, which need to happen, that will become huge, right? And I'm expecting, players like Reliance and others becoming very, very important in that context, because, they control a large part of the 5G networks, but also, a large part of the handheld devices, right? And obviously, the government regulations will tighten that. Even if you want to train models locally on your phones, you can't take that data away. And you can't take any insights from the data which exposes something about your privacy, right? And that also needs to be left out, right? So that field becomes, huge of relevance, specifically in countries with, larger population. Yeah.
I mean, I can already tell, federated learning is something that I'm already very excited about, and I think it's going to be really interesting to see how that evolves, especially again in countries like India where there's so much data being generated,
Yeah.
and specifically something that I think is really fascinating is recently Google had this new technique where they were able to extract raw training data from different language models. So you're right, it's going to be again, interesting to see how we can cleanse these models to not only be accurate and unbiased and explainable, but also make it so we can't just extract people's personal data directly from the weights of the models themselves. So that's going to be, again, an area of research, I'm sure.
And I think this is like just one of those, like how much can government know, or how much, the different private corporations in your country know about you, right? And that's an area which is ripe for explosion in India, because I do believe there is a lot of focus on some of these things in the Western world, right? But there is a lot of potential for this field to evolve. I could see startups and companies coming up which are essentially, just charging and just, creating products to actually protect this consumer data, right? Because there are a large number of consumers. Not everyone is educated to that extent, um, or, receptive to that extent to tighten. Even if you are being told, hey, thou shalt disable this on your phone, right? The just the general aspect of education becomes so important with such large mass population, right? So these are the industries which will, start cropping up a lot, and we will see companies, right, which are specifically playing in that space. Yeah.
Absolutely. I think education's definitely a big part of it because it's kind of ironic how education is like the one industry that's supposed to prepare people for the future, and yet it's the one that I think gets the least attention to the attention it deserves ratio, right? It's not exactly balanced in the way that it should be, but education has to evolve. It already is. There are some folks that are really enthusiastic about changing it, making it evolve, making it actually use new technology and teach kids about industries that we don't even know what industries will exist in the future. So if we can't prepare kids for the ones that are at least visible for the near future, they're not going to be ready for the far future at all. So I think that's definitely really important. Speaking of which, we actually have a question from LinkedIn. This is from Jitender Sharma. She's asking, I have a question. I've been in the HR domain for the past 5 years. Is it possible for me to switch into data science, AI, and machine learning? If so, what steps do I need to take? Now, I know, Animesh, you're really excited about helping the developer community and that sort of end of things as well. So I do want to ask, what are your sort of tips for people to get into the world of AI and machine learning, especially if they're coming from another domain, like, for example, Jitender coming in from HR?
Um, that's great, and I think, a lot of people in HR are very, very well poised, actually, to be great data scientists. We have personally experienced that, right? So we worked with a very large retail provider in US, right, where they wanted to actually look at their HR data, because HR people are, constantly crunching a lot of data, right? They're looking at, different characteristics of candidates who are either employed by the company or who are coming in, right? So you are familiar with data, and having that comfort, being able to look at data and being able to drive extrapolations out of it, that readily plays, right? We have seen a lot of people from that field actually converting and using more and more data science, right? And again, I think ML and AI become too heavy-headed word. Even if you are, doing some of these techniques in your day-to-day jobs, like, you are looking at data and you're saying, if you can do more analysis, okay, based on the churn, like, 30% of the employees, who at this point moved out of the company, right? I can probably predict that in this month, there will be 10% more churn. Simple things like that. You are becoming a data scientist, right? You can just look at their data and start extrapolating in terms of, what is where the future is going to go, right? Even in terms of the recruiting and hiring practices, right? Okay, the data is telling me that we are hiring a lot more males than females, right? This data set is biased. Just as simple an analysis like that makes you a data scientist. So I mean, that's just, the conceptual view of it, right? But yes, in general, in terms of practice, right, I think the great thing is, the we are all mostly aware of the great learning skills networks like Coursera, Audacity, and others, right, which are heavily providing a lot of courses to actually get practitioners started. And I think the place where I will focus if I'm getting started in this is, um, the simplest way to begin is around, look at data science. I think we can go on machine learning and AI side a little later on, but if you can do data science really well, you are already there. And even from that perspective, more simplistic relational databases, right, are a good place to start, right? You don't have to be looking at, more complicated, natural language understanding or document databases, or, data unstructured database residing in Hive or S3, even if, it's a relational table which you have in a relational database, and that's starting to give you insights, right? But then, combining it with more professional level courses at Coursera, Audacity, right? These are great. If you do want to leverage more and more open source tools, because I think that's an inexpensive way to get started. I mean, a lot of cloud providers or the major cloud providers, right, do provide, free tiers, right, where you can actually go and launch their, for example, you can go on Google and launch Google Collabs. Notebooks are a great place for a lot of people to get started. For a large part, they remain free, right, unless you start hitting certain limits. Definitely, even Watson Studio on IBM Cloud has a lot of free tiers and limits for you to be using those tools. But if you don't, the open source technologies are spread around. So I would suggest, just Google for LFAI landscape, which is, Linux Foundation AI landscape. And that will take you to a page, and I can send you send a link to the Tanmay, he can post it, which has, a list of like all the relevant and important and free open source projects which are there, right? Projects which you can run on your laptop, right? Just to get started. So something like, for example, Apache Superset. I mean, Apache Superset is a great tool, totally free, out of the box. You can run it on your laptop, and you can point it to a relational database, and you can start creating these amazing graphs, just right out of the box, right? And huge visualization capabilities, being able to query your data set, insert rows, uh, and it's all just available by, 5-minute install on your laptop, right? So there are many tools like that, which are there in that LFA landscape, right, which you can just run on your laptop, get started for free. And that, combined with the free tiers on these different cloud providers, that combined with, some of the free courses which are available in Coursera and Audacity, right, that gets you right there. But again, given that you're in HR, trust me, you have a propensity and a natural inclination in terms of looking at the data and drawing some inference. So just keep on advancing that, the sixth sense, as I call it here.
Keep advancing your sixth sense, absolutely. I mean, I never really thought about it that way, but you are right. People in HR already are, predisposed to so many techniques and just things that they do in their everyday sort of role that they're already sort of on track to being a good data scientist or machine learning developer, right? So I think just there, keep on your journey of learning AI. And I mean, as mentioned, I will be linking to the Linux Foundation. What was it called again? The Linux Foundation
LFAI landscape. I'll send
AI
a certain
landscape.
set of links,
Perfect.
and then, hopefully you can post it to your audience after that.
Wonderful. Linux Foundation AI Landscape. I will be sure to link that in the description below, and let us know if you have any more questions regarding that. Another way that you can get into machine learning AI, I mean, we mentioned, we mentioned Coursera and all these different, online platforms. There's also platforms like Cognitive Class where you can learn how to program and, use machine learning technology. And I also have a series of videos on my YouTube channel around learning deep learning from scratch. So make sure you take a look at that as well. Now, from there is one last question that I want to talk about. This one's from YouTube. Um, this one is from from a viewer named Sohan. Sohan's asking, can we create AI who can generate code to perform specific functions and to solve problems itself? So use AI to generate code. I would say that's a bit open-ended. Before I hand that off to you, Animesh, one thing I will say really quickly is that I've seen a little bit of work into generating code with AI. I know IBM Research has actually done a little bit of work with that as well, as to like analyzing code and generating code. But one of the things that I think is really important to understand about coding is that coding is traditionally viewed as one of these like monotonous statistical mathematical activities that people do, right? It's like it's boring, it's work. What a lot of people don't realize is that writing code is actually more of an art than it is anything else. Right? Like, this is actually one of the things that I mentioned at my keynote at the Creative Foundation as well, is that when you think of creativity, you usually think of like music. You think of maybe a painting or something of that sort. But really, coding is just as much creativity as anything else is. And the reason I say that is because a lot of coding isn't just writing code, it's thinking, how do you architect the code to solve a certain problem, right? How do you figure out the logic that you're going to be implementing? Why do you choose that logic in specific? There's so many questions that go behind coding versus just actually writing the logic in the form of code. And so I would say that fundamentally, AI can be very helpful to creative professionals. That was the entire point of my, auto lyricist project of generating lyrics. Is it can be helpful to creative professionals, but it doesn't replace them. It augments them. So I would say that while it could be possible to use AI to help programmers write code more quickly, I don't see AI taking a vague linguistic description of a problem and turning that into fully functioning algorithmic code if it's never seen that logic before. Now, GPT-3 might be really good at spitting out code that it's already seen based off of some sort of description, or even putting together different, sections of code together that happen to compile, but it can do that reliably enough with complex enough problems to actually be useful as an auto coding tool. But still, though, that's what I've seen in my sort of experience, right, as a developer. Now, I want to know what you think, Animesh. Do you sort of agree with what I mentioned there? What sort of work have you seen with AI writing code for itself?
Yeah, no, definitely. I think I really like, the way you put it, like, the creativity aspect of coding, right? And as with everything, right, AI, uh, is really getting good at doing a lot of things, right, which have more predetermined inputs and the outputs which you can predict with a more confident manner, right? But creativity is one thing where still there is a lot of room to improve, right, in terms of being able to determine methods and methodologies, right? So I mean, there are attempts, and this is a field just in general, the low code and no code movement, which is thou shall not be required to write any code at all, right? That is gaining steam. Uh, Quite a bit of it with AI, but a lot of it without AI, right? So if you see the proliferation of drag and drop technologies which are coming up, where essentially, the whole notion of being able to drag and drop things on a palette, right? When you actually give the problem and then it comes up with a set of predetermined functions, right? So if you see the advent of serverless, right? One of the things, right, which there are projects which I've seen where essentially there are functions to do some very specific things like send an email notification to someone, or do addition of these 5,000 numbers, or run a strong for loop or a while loop. And what is happening is, based on the problem set you define in these low code IDs, right, and then it can point you and recommend you certain functions which you can drag and drop, create a flowchart on your palette, and boom, and you generate a template code. But again, to the point is, it's a template code. You still need to go and then do your manual intervention to make that more robust. Right now, when you come to AI, just AI specifically, there is a tool which IBM Research launched called CLAI. It's in github.com/IBM. So command line AI is essentially a tool which is taking it more at single building blocks where you actually type commands,
right? And a lot of the commands which you actually run on your, for example, bash commands, Python commands, etc., which you run on your command line tool, you essentially then end up, embedding it in your program, right? So CLI essentially, is using AI under the covers to recommend you, okay, based on what you are trying to do, this is the command, run this command, that command, right? So I think these are the building blocks of being able to take you towards that experience. A lot of the IDEs, right? Obviously, you already saw some of the things like code completion, right? Where, you get uh, more and more, code completion tips and tricks, right? Which you can choose as you are trying to start your writing your code, right? And they are now becoming a little bit more robust, and people are, looking into the field of being able to train based on, the type of code you typically write, right? What sort of algorithms and functions to recommend you. I would say still an evolving field, and definitely, something which a lot of people are looking at, right? Because there is this whole notion of, and the movement towards no code and low code. But definitely look at CLAI from IBM Research, right? It's using AI under the covers, right, to make your command line experience much, much, much easier. Typically, one of the ways I program is I run a lot of commands on command line, then, translate it back to my programs, right? So that's definitely making me productive in that context. And yeah, uh, we, and I think the other part is, depending on, if you look at the code itself, which is, the machine learning model, they are pieces of code, right? And that field is definitely advanced, right? So AI to write AI code, in a sense, I mean, the fields of auto AI and neural architecture search are essentially going into these areas, right, where they're leveraging, huge powers of compute to begin with, right, to create this, set of 20, 30, 50, 100 models for you, which are essentially pieces of code, right, in the end, which you can then deploy. But then, over a period of time, there are now techniques being evolved where even, how much of optimized neural architecture search you should run, right? So for example, if historically an enterprise customer is being able to produce the right model they need in 50, or let's say 20 iterations, then if somebody comes in later on and say, hey, run 70 iterations of this, they're actually interjecting, hey, your success rate when you are actually running neural architecture search and producing, like, for example, 20 models, or you are using hyperparameters in this range, has been more. So thou shall revert back to that, because you are getting more success. We are being models being chosen from that particular. So even with that, combining the neural architecture set search with now more recommender based technologies of AI are being used to produce more optimized, less resource hungry auto AI techniques, right? So, but that's AI is sort of helping to produce more AI code, right? Generic code, I think there can be a lot more focus in those areas. Yeah.
Yeah, it's going to be fun to see, because I feel like when we can create machine learning systems that do a better job at actually understanding logic and reasoning well enough to be able to actually help humans write code more actively than it does today. I mean, it's already kind of helping, right? We see services like Kite and Tab9 and CLAI, right, from IBM Research, that are already sort of working towards helping coders with AI technology. But when it can do more, I feel like that'll be great just in general, because then we'll have these sorts of machine learning algorithms capable of the reasoning required to do such a thing. Now, there are a couple more questions. I'm going to be quick with this one. There is a question from Sarmista asking, please upload more AI course videos on the channel. I will be doing that. I already do have a series, Learn Deep Learning from Scratch. I will be continuing that very soon, as well as an interesting question from Surbi on the live stream asking, is data the only thing through which a machine can learn? The reason I love that question is because it gets into the very naming of machine learning. When I saw this question, it really was thought-provoking to me, because, I mean, if you think about it, with machine learning, machines don't really learn, right? Machines aren't necessarily learning per se the way that a human does. But rather, what we're doing is we're saying, here's a bunch of numbers. How can we find just the right numbers? Well, here's a bunch of slots for numbers, but how can we find exactly what numbers to put in the slots such that when given X, we're able to produce Y consistently, right? And what happens is the emergent behavior from that to us looks as learning, or looks like it's intelligence. right? Like for example, if we were to do, here's X, an image, and Y is a label, cat or dog, figure out if it's a cat or a dog, to us, the quote unquote behavior from that looks intelligent because, visual processing that's associated with intelligence innately for us. Same thing with natural language. When we see GPT writing text, that's associated with intelligence for us. But at the end of the day, what's happening behind the scenes with this machine learning technology is still just, hey, here's X, here's Y, let's figure out the best mathematical function. Best, I say, not necessarily globally best, but, a good mathematical function to go from X to Y. So I would say that it really depends on what you mean by learning, what you mean by machine learning, and a lot more. But in general, with the machine learning that we have today, I think data is quite literally at the heart of it. But Animesh, what do you think?
I mean, the thing is, as soon as you translate anything of essence to computer bits and bytes, it becomes data, right? Yeah. So I think just the general broad term for data, which we use in the industry, for computer to understand it, it has to be in the bits and bytes format. And as soon as you transform any information into that, like even if, for example, I was, and this is definitely a thought-provoking question, right? I mean, how fast the wind is blowing, right? Can you just determine from a force? A human can give an educated guess, right? But as soon as you want a machine to do it, that information gets translated to bits and bytes, and that becomes data, right? So I don't see a way out of it, right? Because the bits and bytes is the definition of data for machine, and at least in the current thinking, right? Unless and until we change the definition of data, right, or what a machine in this case, a computer can understand, right, to do something more meaningful out of it.
Yeah, I mean, data really is at the heart of computers in general, as you mentioned, right? That's something that I completely overlooked, is that if you're working with computers, you got to be working with data fundamentally, right? You're working with bits, you're working with bytes, so it's something to definitely think about. But those were the questions that we had today. Thank you very much, Animesh. I know that we went a little bit over time, but this was a really interesting discussion. Thank you very much for joining us today. I mean, I've personally learned a lot. I'm very excited. And this was the perfect sort of starter for next week's conversation on TechLifeSkills, more about, ethical usage of artificial intelligence and trusting AI and using it for good. And so we will be talking about that next week. Make sure you join us next week, 46th episode of TechLifeSkills with Tanmay at 11 a.m. Eastern Time. But before we leave today, Animesh, I do want to ask you, based off of this conversation we've had and the questions we got from the audience, what is it that you want to leave our viewers with today?
First of all, thanks for having me here, Tanmay. And again, congrats again for, getting recognized from the government of Canada, from the Prime Minister, right, just indirectly, right? So that's an awesome achievement. Keep on doing the great work. And I can see personally, I followed your career trajectory, right from the beginning. When you were such a little kid, right? But I think, by being in the show, right, I can greatly see, right, the amount of knowledge and the amount of information sharing you are doing in terms of making, the world a better place in terms of being able to understand the AI, right, and educating the masses. That's a great initiative, right? So I really love the interaction, and I really loved, a lot of the questions which are coming, which are, very thought-provoking at certain context, right? And also things like which are looking at this from a more country-specific things, like, for example, where does, for example, India will have the next and number of most productive use cases in AI, right? I think we typically in our role, we tend to think more in terms of where the general landscape is going. What are the next 3 years where we will see most specific use cases? But yeah, when you start diving into country-specific niches, some things might be more prominent than others. Like, for example, just the number of farmer population in India, right, gives it a huge use case where, we will see a lot of digital farming initiatives being made available. So yeah, no, all in all, a great interaction. I think I would say, in terms of looking, there are few things, Linux Foundation AI landscape, which is your list of, all the open source projects which are out there. If you are the one who is essentially looking at running machine learning on Kubernetes, definitely, Kubeflow is your go-to place, which has projects, from build, train, deploy, and manage. so being able to launch Jupyter notebooks on Kubernetes, being able to run hyperparameter optimization techniques, being able to run neural architecture search, then validate, and then deploy your machine learning models in production, do canary rollouts, being able to detect bias, explain model predictions, do adversarial detection, outlier detection, all that in that one single platform. And then it gives you machine learning pipelines by virtue of Kubeflow pipelines, which essentially automates this whole cycle. And not only these pipelines take you from point A to point Z, it also creates behind the scenes a strong metadata lineage and governance so that you can go back and look if my model was giving a prediction which was not desired, on what data set it was trained on, what version, for example, of TensorFlow was used, what were the hyperparameters used, so you can trace back the whole lineage. And this is, so this is working two ways, these machine learning pipelines taking you from point A to point Z. And then if you need to trace back from Z back to A and back to C, all these techniques are available there, right? So very, very strong project you should look at. If you're working to set up these machine learning platforms on Kubernetes, or leveraging, machine learning capabilities on Kubernetes, or regardless, like you can run versions of Kubeflow pipeline on your laptop, right, using Docker. So that's great. So we talked about Linux Foundation AI landscape, and then, the Kubeflow project. And specifically, the third thing I will say, LFAI, Trusted AI. So that's a committee, right, which I'm chairing. I'm the North America chair. There are companies from Asia, Europe, which are participating, right? So there is Tencent, Orange, other companies, like, so around 14 companies, right? And if you are part of an organization or an initiative, right, which is interested in this field, right, we would definitely love to have you there, encourage you to actually join that and advance the mission of Trusted AI with us jointly, right? Apart from the right thing to do, I think this is something, right, which will also commercially gain a lot of prominence because of the regulations coming in, where the most of the enterprise model providers will need to comply with these regulations, right? And they will need to make sure. And otherwise, just reach out to me for anything else, right? I'm always available. And great chatting with you guys. Yeah.
Thank you very much, Animesh. It was great having you on the show. I mean, I learned a lot today, bringing the engineering rigor into a field that's traditionally had a lot of science rigor, and being able to have the infrastructure and actually build out new infrastructure really to really fit towards the unique challenges, the unique problems, the unique situations that AI technology brings to the table, all the way from, deploying models to customers and understanding bias, and that sort of that last mile analogy. I think that's actually perfect from the logistics world. And, once it's actually in a certain area, how do you bring it to a customer? How do you actually deal with that last bit of interaction? I think is really important, and something that maybe we don't think about as often, maybe isn't as glamorous really as the science or the, raw, hey, here's what we can do. But it's amazing, going back to your analogy of the AI model was built in 2 months, but it's been 11 months since we've been able to, or rather, we still haven't been able to, bring it out into the real world. A pretty similar analogy to, I believe it was the Moderna vaccine. It was it was developed in like 2 days, literally 2 days, but then it took a year just for, approval and the clinical trials and all the logistics and everything to go through, which in and of itself usually takes way longer, but was accelerated greatly to just a year. So, it's amazing to see. And it was really insightful, hearing from you. So thank you very much for joining today. This was a really exciting episode for me. Make sure you join us next week, everybody. Once again, we'll be talking about AI for good and the ethical usage of artificial intelligence. So thank you very much, Animesh. Thank you very much, everyone, for joining in today, and goodbye.
Goodbye. Thanks, Tanmay. Thanks, everyone.